The next topic that we are going to study is the Pythagorean Theorem. The Pythagorean Theorem is only used with right triangle problems. When do I need to use the Pythagorean Theorem? Well, you can use it when you know the length of two sides and you need to know the length of the third side. So when you have a triangle and you know two sides and you want to find the third side, as long as it's a right triangle, you can use the Pythagorean Theorem. What is the Pythagorean Theorem? So the Pythagorean Theorem is a formula, a squared plus b squared equals c squared, where a and b are your legs and c is your hypotenuse. It doesn't matter if you switch a and b, but they have to be on the legs and c has to be your hypotenuse. So when you use the Pythagorean Theorem and this formula, you're looking for, let's start with the problem where you're looking for the length of the hypotenuse. So in this problem, we know that the two legs are 15 and 20, and we're looking for the hypotenuse. So first off, we start by writing the formula, and you always start every problem by writing the formula a squared plus b squared equals c squared. Next, you're going to substitute the information you know. So in this case, I'm saying that a is 15, b is 20, and c is unknown. If you switched them and said that a was 20, b is 15, and c is unknown, that works. So then the next step, you're going to square them. So 15 squared is 225, 20 squared is 400, and it is equal to c squared. Then you add, so you're combining your like terms, so you have 625. So c squared is equal to 625. When you take the square root of both sides, you get c is equal to 25. Okay. Another way to use the Pythagorean Theorem is when you're looking for the length of a leg. So you're given a hypotenuse and you're given one of the legs, but you're looking for the other leg. So in this case, we're given one of the legs is 6, the other is x, and the hypotenuse is 10. So again, you start by writing the formula, a squared plus b squared equals c squared, and substituting in. In this case, I'm saying that b is my unknown. If you switched a and b and said that a is your unknown, that's fine too. So we substituted the information in that we knew, and we can square everything. So 6 squared is 36 plus our unknown, b squared, is equal to 100. Then we're going to subtract 36 from both sides to get that b squared is equal to 64. And to solve this, you're going to take the square root of both sides and get b equals 8. So let's apply the Pythagorean Theorem. I'd like you to try these problems as I go through them to make sure that you understand it. So a way to apply the Pythagorean Theorem, we have a 15-foot ladder that leans up against a building. The foot of the ladder is 5 feet from the base of the building. How high up the wall to the nearest foot does the ladder reach? So we're going to start by drawing a picture. So we have our building, and our building is right here. Okay, and then this is the ladder that's leaning up against the building, and here's the base. So the ladder is 15 feet. The base of the ladder right here is 5 feet from the wall, and the wall, we don't know how tall it is, or the building, we don't know how tall it is, so we're going to call that x. So now we can use the Pythagorean Theorem to solve this problem. Okay. We start again by writing the formula, and then we substitute in the information that we know. So we know that x squared plus 5 squared is equal to 15 squared. When we square each of the numbers or each of the variables, we get x squared plus 25 is equal to 225. We're going to subtract 25 from both sides, and we get x squared is equal to 200. So we know, let me go back. We know that x is equal to the square root of 200, but we have to think about the problem. How are we going to leave our answer? It's not looking for the square root, okay? It was looking for how far up the wall the ladder reaches. So in this case, we can't leave it in a square root. We have to put it in a number because we would like to know how far up. So the ladder reaches up about 14 feet on the wall. If you rounded your answer to 14.1 or 14.14, that's fine too. But for this problem, we can't leave it in a square root. All right, here's another problem. Tim rode 8 miles due north, then 3 miles due east. So how far to the nearest mile is Tim from where he started? So again, let's start by drawing a picture. Tim is riding 8 miles north and then 3 miles east. So we want to know how far he is away from where he started. So we're going to call that x. We're looking for the hypotenuse. So let's start by solving the problem with the formula a squared plus b squared equals c squared. And notice we're writing that every single problem we are doing. So I need to see that on your paper every problem that you are working with. We're going to substitute in the information that we know. And we get 64 plus 9 is c squared. So c squared is equal to 73. So we know that c is equal to the square root of 73, but we have to remember the way that we're supposed to leave our answer and what the question is asking. So we know that c is equal to about 8.5. So the question was saying, how far is he from where he started? He's about 9 miles from where he started, or 8.5, 8.5 miles from where he started. All right, so here's some other problems that we can use the Pythagorean theorem for. If we are given a rhombus, and we know that the diagonals of the rhombus are 6 centimeters and 8 centimeters, what is the length of each side of the rhombus? So we have to think back to what we just did last unit with quadrilaterals and the properties and characteristics that we learned about quadrilaterals. So our prior knowledge is what properties does a rhombus have? So take a couple minutes and think back to what properties the rhombus has. And you can look back in your notes to do this, but we should have a good understanding by now what properties a rhombus has. So first off, we know that the diagonals of a rhombus bisect each other. The diagonals of a rhombus are perpendicular, and the sides of a rhombus are congruent. So with that information, we can use that information to help us solve this problem. First, we're going to draw a picture. So we have our rhombus, and we're going to draw our diagonals in. And if we know that the diagonals bisect each other, then this right here is 3, and this is 3, because we said the diagonals are 6. We also know that this is 4 and this is 4 because our diagonal is 8. And we're looking for the outside of the rhombus. So we put an X here because we're trying to find out what the outside of the rhombus is, or one of the sides of the rhombus. So we can start with our formula a squared plus b squared equals c squared, where we know that a is 3, b is 4, okay? Because here, if we know that this forms a right angle right here, and we know one of the sides is 3 and one of the sides is 4, we can find the hypotenuse. We can do the same over here. This is a right angle. This side is 3, that side 4. We can find x. So we know that c squared is equal to 25, so c is 5. So one side of the rhombus is 5 centimeters. Or each side of the rhombus is 5 centimeters. Therefore, if I continue and say find the perimeter of the rhombus, you can say that each side is 5 and add them all up. When we're solving with rhombuses or rhombi, we have 4 right triangles, so this is really easy to use Pythagorean theorem with. All right, we have a longer problem here. As seen in the accompanying diagram on the next slide, a person can travel from New York City to Buffalo by going north 170 miles to Albany and then west 280 miles to Buffalo. First, if a highway is built to connect New York City and Buffalo, how many miles would be saved on the trip? And then the next question we're asking is, with gas prices at $3.10, which is very low at this point, and a vehicle that can get 18 miles per gallon, how much money would be saved round trip if the new highway was traveled instead of the old route? So I'm going to post the answers on this. I want you to take some time. You can pause this video and solve this problem, and then check your answers with my answers. So the very first thing we need to do is draw a picture. So that way we can find the length of the new highway. The new highway we have in question marks here, okay? So we're going to start by setting up our formula, a squared plus b squared equals c squared, substituting the information in till we get the c squared is the square root of 107,300. So c is about 328 miles. Okay. The next thing we have to do is, did we answer our question? Well, the question was how many miles would be saved, not how many miles you traveled. So now we have to do a little bit more math. So the old distance took us 280 miles plus the 170 miles. So we used a total of 450 miles going the old distance. The new distance was 327.566 miles. So when we subtract them, we get that we saved about 122 miles. The next question asked us how much money can be saved. So we take how many miles that were saved and multiply them by 2 to get 244. And then the cost to drive 1 mile, we have $3.10 divided by 18. Okay, so we get about 17 cents per gallon. So then the cost to drive 244 miles, we multiply it and we get that we saved $42.02. All right, let's wrap it up. Let's see what we learned. The Pythagorean theorem can be used only on blank triangles. Go ahead and take a minute and fill in the blank. The next, when should the Pythagorean theorem be used? The third question is, what should be done first when solving a word problem involving the Pythagorean theorem? And then the last one is, what must be done before writing the answer to a Pythagorean theorem problem? All right, so for the first one, our answer is a right triangle. It can only be used on a right triangle. The second one, the Pythagorean theorem should be used when the length of 2 sides are known and we need to find a third side. The first thing that we need to do when solving problems, word problems with Pythagorean theorem, is draw the picture and label the triangles. And then what must be done before writing the answer is to check to see what answer is needed and whether we need to round it or take the square root of it, put it in decimal form, what we need to answer. And that is the end of our lesson today. Go ahead and take a few minutes to answer the questions on Kia with Pythagorean theorem to see how much you learned about Pythagorean theorem.